Hello, welcome back to Maths Mars Physics, and in today's video in forces we're going to be looking at forces but working horizontally. So in the last few videos we've been doing forces vertically, right, like how forces work a little bit vertically, but this video is going to be explicitly horizontally. So how are we going to start this video off? Firstly, we're going to want to find as much information as we can to kind of help us later on this video. So first we're going to write down F equals ma, and so this is going to be the force, right, total force, which is being exerted here, which we're hinted here 40, is going to be equal to the total mass, which is 2 plus 3 is 5 times a. So we know already off the start that our acceleration is 8, and for these purpose of these videos I'm not using units, but you will need to use units in your own classes for physics. And let's continue. So what are the forces here being applied? Well, there are 3 points of forces, right? You might first think that since we've been doing the last videos, there's just going to be these vertical ones, right? But there's also one more, which is over here, which is the horizontal one. So N1, N2, and N3. And so you know that those work the other way. I'm not going to write it just so that you can save some time. And so I know that you guys know how to solve for N1 and N2, right? These are very, very simple. N1 minus 2g equals 0. And 2 minus 3g equals 0. So now you already have, boom, N1 is equals to 2g, and N2 equals to 3g. So that's what you have, right? But the one that's a little bit trickier is this N3 over here, right? Which is what we haven't encountered yet. And for that, we're going to write an equation, right? So we have here 40 going in, right? Because, you know, I wrote it out there. It's the same as me writing it in there, right? And so looking at our coordinate system here, which we've been using in the last few videos, it's going to be, so make sure you go back and watch this if you don't understand this. It's plus, plus, minus, minus, right? And so here, since this is moving to the right, it's going to be positive, right? So this is going to be 40, right? And then think about it the same way we've been doing vertical problems, right? Where you did the vertical and the vertical addition and the subtraction. It's going to be the same way horizontally, right? So you're adding 40, and you're subtracting N3 here, right? Because this is moving to the left. So 40 minus N3 is going to be equal to our net force here, which is going to be actually not 0, is going to be 2a, right? And that's because this equation comes from force equals mass times acceleration. And so this is the total force, right? The total forces equals the mass, which is 2, which is what's being pushed on, times the acceleration, which is something that we don't know, right? So you're always thinking in terms of force equals mass times acceleration. So now what we know, a, right? So now 40 minus N3 equals 2 times 8, which is 16. So 40 minus 16 equals N3. So N3 equals 24. And now you have solved for all N3s. So you could do the same thing with the other side, but this 2, working with this block with 2, I feel is easier for me. And yeah, so that's how you do this problem. And that's how you got N3 is 24, right? And yeah, that's all for this video. Thank you.